welcome to Most Significant Bit, a podcast that explores connections between engineering technology and the arts. I'm your host, Mercedes Tobias. In this episode, we will discuss how almost 1 billion birds die annually in the US alone from window collisions. We did a deep dive into the engineering solutions to fix this. I'll explain what birds see, how scientists evaluate glass visibility for the birds, and how cities incorporate this technology via modern building standards and ordinances. Birds collide with glass because they lack binocular vision and mistake reflections for open habitat. These are birds with monocular vision, such as pigeons, robins, and chickens. Monocular vision is when one eye transmits data to the brain instead of the two eyes combining into one image, like humans do with binocular vision. The owner of a glass company's friend mentioned an article about orb-weave spiders. The friend stated, "Its web reflects UV light, protecting it from being destroyed by birds, as they can see it and do not fly through it." The idea of developing a coating for glass was conceived that night. This led scientists and engineers in Germany to create an ultraviolet coating that mimics spider webs in 2000. They tested the coating in a flight tunnel at a U.S. nature reserve. In 2001, Arnold Glass patented the concept, and by 2006, Ornolux Glass was born. By 2010, the current Makaido coating, which uses a pickup stick's random pattern, was released. The best practices are shifting from the traditional 2-inch by 4-inch industry rule to a tighter 2-inch by 2-inch grid pattern to protect smaller species like hummingbirds. Testing bird-safe glass patterns for the safety, compliance, and material durability is required by most municipalities. The American Bird Conservancy is the leader in testing and standards. There are 2 testing facilities, the Carnegie Museum of Natural History's Powder Mill Avian Research Center and Washington College's Foreman's Branch Bird Observatory. There are tunnels that are 24 foot long, made of plywood. A professional will examine a test subject bird prior to testing. If the bird shows signs of distress, the bird is released and a secondary is selected. The bird's band number is recorded and then it is released into the tunnel. At the end of the tunnel are 2 glass options: the control plain glass and the subject glass. A fine net is drawn taut at the end prior to the glass to safely stop the bird from actually hitting either panel. Birds only complete the test once and then are released. A threat factor is assigned. This scoring system uses at least 80 test runs with varying bird species. The percentage score is set depending upon how many birds fly towards the test subject material. If 40 out of 80 birds fly towards the material, then it is rated at 50%. The lower the score, the better. Only glass with a threat factor less than 30 are defined as bird-friendly. The modern safety markers must protect wildlife without ruining architectural integrity or failing under environmental stress. The glass must also pass traditional glass safety standards set by the International Building Codes. Incorporating bird-safe tech into building ordinances is the first step towards protecting birds from modern architecture. To meet the high demands of the construction industry, manufacturers must find simpler ways to create the product in a shorter timeline. Large-scale manufacturing is driving down production costs, allowing developers to meet new city building mandates seamlessly. Bird-safe glass with UV coatings can add between 15 to 40% extra to the total cost. There are other aftermarket film solutions that can bring this additional cost to a range of 3 to 15%, making it easier to comply with laws like New York City's Local Law 15. This law dictates that new construction and major exterior renovations must use bird-friendly material on at least 90% of the first 75 feet of building facades, green roof zones, and any transparent fly-through corners to prevent fatal bird collisions. Some of these patterns are embraced as architectural features, such as the Ornolux with lines featured on the Porsche Design Tower in Stuttgart, Germany. Today we covered how bird-safe glass protects birds from collisions, using science and engineering technology in urban architecture without noticeable impact on the overall human experience. Thanks for listening!